Welcome to our next example of solving irrational inequalities. This problem is slightly different from what we've been doing before because now we have two radicals being added together on the same side of the inequality. But our first step is still the same. We have to find the domain restrictions on x. Everything that's inside a radical must be non-negative. Setting these two expressions to be non-negative, we solve and we have x is greater or equal to negative 1/2 and x is greater or equal to negative 1. Taking the intersection of these two conditions, our domain is just x is greater or equal to negative 1/2 because this automatically satisfies that x is greater or equal to negative 1 as well. We're first going to square both sides of this inequality. That way we can get rid of some of our radicals. We get 2x plus 1 plus 2 times the square root of 2x plus 1 times x plus 1 plus x plus 1 is less than 1. Now let's combine like terms. We have 3x plus 2 times the square root of 2x plus 1 times x plus 1 is less than 1. Now we can try to isolate the radical term by itself so we can square it later. Let's move all the terms here to the right-hand side of the inequality. On the left-hand side, we have a positive number times a radical, which means it has to be positive or 0. And since the right-hand side of the inequality must be greater than positive or 0, this right-hand side of the inequality, which is negative 3x minus 1, must be strictly positive. So now we're adding another restriction on x. If we simplify, we get negative 1 is greater than positive 3x, and so x is less than negative 1/3. And since we still have a radical, we're going to go on and continue to square. We have 4 times 2x plus 1 times x plus 1 is less than 3x plus 1 squared, which is 9x squared plus 6x plus 1. We're going to expand the left-hand side into a polynomial to get 4 times 2x squared plus x plus 2x plus 1. This becomes 8x squared plus 4 times 3 is 12x plus 4 is less than 9x squared plus 6x plus 1. And now we're going to move all our terms to the right-hand side of the inequality. X squared minus 6x minus 3, all this is greater than 0. Since we're left with a quadratic, we just have to factor this quadratic and solve. If we do a quick sketch, this horizontal line is when y equals 0. This parabola is upward opening because the leading coefficient, in this case it's 1, is positive. That's why it's upward opening. And this parabola will only have negative value if we are between its two roots. So we have to find its two roots now. Because this quadratic is very hard to factor out itself, all we can do is apply the quadratic formula. The quadratic formula says you can take the negative of the second coefficient, 6, plus minus the discriminant, which in this case is 36, plus 12, all that over 2. You're left with 6 plus minus the square root of 48 over 2, and square root of 48 is equal to 4 times square root of 3 over 2. And this, let me write it over here, is equal to 3 plus minus 2 times the square root of 3. So now we know our two roots. So 3 minus 2 times the square root of 3 and 3 plus 2 times the square root of 3. It's only positive when x is beyond these two boundaries. So only positive when x is less than 3 minus 2 times the square root of 3, or x is greater than 3 plus 2 times the square root of 3. And if you want to know the approximate values of these two roots, it would be, the first one will be about negative 0.464, and the second one, which is a higher one, would be about 6.464. Now all we have to do is intersect our interval with the constraints. Our first constraint is that x must be greater or equal to negative 1/2. And remember, our upper bound was that x must be less than negative 1/3. If we draw out a number line to see where all this fits, we calculated x to be less than negative 0.464 or greater than 6.464. But our domain says it must be greater or equal to negative 1/2. And we also said that it has an upper bound on negative 1/3. So that would be about negative 0.33 going this way. Now we have to find where does all three of these colors intersect. Well, that would be in this window right here. That's where all three of these conditions are true. So our final answer would be x must be between negative 1/2 and 3 minus 2 times the square root of 3. The first one is closed, second is open interval. And that's our answer.